Educational Communications and this station present Environmental Directions with Nancy Pearlman. On this series, we explore the effects of human influence on the Earth's ecosystems and discuss solutions to environmental problems which affect the quality of life on this planet. Environmental Directions gives you the kind of information you need to help you participate in decisions impacting your community, the nation, and the world. Now, here's your host, Nancy Pearlman.
Hello. For the next half hour, we're going to be talking about astronomy, the sky, and why it's so important for us to know about the relationship between the Earth and the sky and to protect our environment above us with my guest, David Falk. He is a retired instructor of astronomy at Los Angeles Valley College. He formerly served for 25 years as a full-time instructor of astronomy at the Los Angeles Valley College. He has also been an adjunct instructor of astronomy at Moore Park, West Los Angeles, and Mission colleges. And he has served as a planetarium technician at the Museum of the Rockies in Montana. Welcome. It's a pleasure to have you with us.
Thank you, Nancy. It's good to be with you.
You love the sky, and we all enjoy looking up above us and seeing the stars. It's a little difficult in Los Angeles because of the light. We're going to be talking about light pollution. But first, I want to understand why it's so important for us to understand the relationship between the sky and the Earth, because normally I'm talking about preserving and protecting our ecosystems here on the planet. But yet, what's happening above us with the sun and the moon affects us too, doesn't it?
Yes, there is a vacuum out in space, but we don't exist in a situation where we're not affected by things around us. Now, granted, the sun is very far away. It's 93 million miles on average. It takes 8.5 minutes for light to get to us from the sun, but the sun affects us. We depend on the sun's energy to support all life on Earth. So there's one thing right there that we depend on. We have to keep in mind what the sun does. How does it work? Does the sun vary its energy? These are all things that do affect us. Now, the other thing that ties us to space is this idea that we came from stars. In fact, all the elements that we have on Earth came out of stars. If it wasn't for stars coming into existence in the early universe, going through their lives, they actually created all the heavy elements that we know about today. Those were created inside the cores of these stars, and some of these stars were very unstable. They blew up, and that's what released these elements into the universe, into clouds of gas, and from that, we believe we got our solar system and the Earth. It is no exaggeration to say that we came from the stars.
You mentioned the solar system. What exactly is that?
So when we talk about a solar system, we're talking about a grouping of bodies which could include planets or minor bodies that orbit around a central star. Our solar system consists of 8 planets. It used to be 9. Pluto is still out there, but we don't consider it to be a planet anymore. It's been reclassified as a minor body.
Science definitely changes as we get new information.
Yeah, that brings up another point. Sometimes we hear criticism, people criticizing science because they say, well, you scientists change what you say. That's true, and that's part of the nature of science. We need to be able to incorporate and reflect on new discoveries that are made, and that's where we need to be open to information. But if we find new evidence that says that maybe these things aren't what we think they are, and that was the case for Pluto. Pluto was found in 1939 visually, and at that time, our discovery methods weren't as good. Our detection methods weren't as good as what we have today. So we found this body that seemed to be going in the right direction at a very far distance from the sun. So we thought, okay, there's a 9th planet, and they called it Pluto. Since that time, since 1939, our detection methods, our telescopes and so forth, have gotten a lot better. We've found a whole host of other objects orbiting beyond the orbit of Neptune. These, we think, are part of something called the Kuiper Belt, which are chunks of rock and ice that are circling the sun way out beyond the orbit of Neptune. We think these objects were left over from the formation of the solar system, and it's beginning to look like, well, Pluto is probably one of these Kuiper Belt objects. So some people feel that, well, we never should have categorized Pluto as a planet. It was probably one of these minor bodies, but not knowing that there are more of these things out there, it was given the designation of a planet. So right now we're left with 8 major planets. That's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.
These are the planets that go around what we call the sun.
Right. There are other solar systems out there, by the way. We have found evidence that says that there are over 5,000 exoplanets. These are planets not orbiting our own sun, but orbiting other stars in our galaxy. So these are called exoplanets, extrasolar planets. They orbit around other stars. But our solar system orbiting around our sun, Sol, that consists of the 8 major planets planets, and then we have these other minor bodies. It includes the asteroids, the Kuiper Belt, something called the Oort cloud, which is way out there. We haven't even sent a spacecraft out as far as where the Oort cloud exists, but we believe it does exist out there. And you have comets, things like that, and those are the minor bodies.
What's the difference between a solar system and a galaxy?
A solar system is our local neighborhood. These things exist out a few billion miles out from the sun, which seems like a big distance, and it is. But then we get to an even larger collection of a whole host, something like 200 billion to 400 billion stars out there that all exist in a very large grouping called a galaxy. So a galaxy is a grouping of stars, dust, gas, and yes, there may be planets orbiting around some of these stars, sure. That's a collection called a galaxy. Now, just to put this into perspective, if it were possible for us to take a step out of our galaxy, and our galaxy is big, it's something like 100,000 light years across, which means if you stood at one edge of the galaxy, turned on a flashlight and off, so now we have a pulse of light going across the galaxy, that beam of light would take 100,000 years just to cross the Milky Way galaxy. That's how big it is. And these other galaxies are, some are even bigger, some are smaller. But if you were to stand outside of our own galaxy and look around, you would be surrounded by darkness because the stars generally only exist inside of these large collections called a galaxy. If you look out, you might see some other little fuzz patches around you, but you would not be surrounded by stars. In fact, most of the sky would be dark. Only if you were to step inside a galaxy would you be again surrounded by stars. And there are many, many galaxies out there, something like between 3 and 6 trillion galaxies are out there. I've heard different estimates. And these things, galaxies exist as far out as we can see.
As new technology gets developed, we are making so many new, fascinating discoveries. We depend on not just the satellites that we send up into space or the various probes that we send out into outer space, but here on Earth, we have planetariums and observatories. And I know you provide planetarium shows at Los Angeles Valley College, but what's the difference between a planetarium and an observatory?
Yeah, that could be kind of confusing because they both talk about dome-shaped structures. An observatory is a structure that houses a telescope. And there's different kinds of telescopes that could be made, but generally you're talking about an instrument that observes the sky. It tries to gather information of what's in the sky, and the observatory is a structure that protects the telescope when it's not being used against elements of weather, and of course it has to be able to open, so these observatories generally have some sort of slit or an aperture that they can open to allow the telescope to view the sky. Now that's an observatory. A planetarium is different. Basically, you were talking about something that's indoors. And the term used to talks about a structure, but they actually, some buildings that house a planetarium in it, they call it a planetarium. But the planetarium is a structure designed to incorporate a curved or dome-shaped projection screen. At the center is some sort of instrument that will project an image of the nighttime sky. So it's designed to show you what the nighttime sky would look like from various places on the Earth. It doesn't open. It stays closed, and you sit inside and look at this spherical projection screen.
Here in Los Angeles, we have the very famous one at Griffith Park, but we have yours, and there are individuals who even have observatories and planetariums and telescopes looking out in the sky. I think worldwide there are over 4,000 planetariums.
There's roughly about 4,000 planetariums in the world. Here in the United States, there's about 350 what we call permanent planetariums. These are things that are fixed in place. Like that, you mentioned that we do have a planetarium at Los Angeles Valley College, and so that's considered permanent. It is fixed and bolted in place. There are inflatable planetariums that are around. They are exactly what you might think they are. They're dome-like structures, and you inflate them with a fan or a couple of fans, and the positive air pressure inflates this thing, and you get through an airlock, you go inside and you sit down, and there's your planetarium. You could deflate these and roll them up and take them to a different location.
The observatory and telescope on Mount Wilson up in the Angeles National Forest has had some discoveries made there, very famous. It used to be one of the strongest in the world, but of course here in Los Angeles we have to now worry about light pollution, and they can't see the night sky as easily anymore.
Yeah, that's a problem. It still is a useful location for telescopes. Georgia State University operates the Chara Array, C-H-A-R-A. That's a Center for High Angular Resolution Astronomy. There are 6 smaller telescopes. They're each about a meter in diameter. And those 6 telescopes feed their images to a special light collection device that tries to bring all these light together to simulate a much larger diameter telescope. So it gives you better resolution, a better ability to see detail. Now, the reason why why Mount Wilson is still useful is because it has very stable air. Weirdly enough, the way the mountains are around the city and the temperature, it just allows the air to be stable. That's one of the big enemies of doing astronomy here on the ground or from the ground is the instability of the air. And the air is always moving. The question is how much air movement do you have? What I usually tell my students is imagine that you're standing outside by a pool, a swimming pool, and you're trying to look at the drain at the bottom of the pool. When there's nobody in the pool, nobody swimming there, it's calm air, you could see the drain very clearly. But as soon as that first person jumps into the pool, what happens? You try to look at the drain, it gets all ripply and everything through the water, and if there's a lot of people swimming around, you may not be able to see the drain at all. Now, the drain is, of course, still there, but why you can't see it is because the water is actually distorting the light path. The light is coming in from the sun, going through the water, it hits the drain, bounces off of the drain, through the air into your eye. But if that water is moving a lot, it's going to just change the path of the light so that maybe every fraction of a second you won't get the light at all from the drain, and that'll make it look like it's not there.
I love the way you explain the obvious. Your classes and your programs have been so fantastic, but how many other places in the world have you visited? I know there are famous telescopes in Hawaii on the Big Island. There's a very famous one down in Chile in the desert because it's such a clear sky. And of course, you probably have traveled to see the eclipses.
Yeah, I've been to 2 for 2 so far. I was in the 1991 eclipse that tracked across Hawaii, across the Pacific. It cut through the bottom of Baja California. I was in San Jose del Cabo, and we saw it there. And then it went across the Gulf of California, cut across Mexico, and ended in Brazil. And I was in San Jose del Cabo. We had almost 7 minutes of totality when the moon was exactly in front of the sun. It was quite an experience. We sat in the farmer's field that he cleared with a bulldozer, so that the cows were on the outside of the enclosure and the humans were on the inside. There was 500 of us. It looked like the aliens had landed with all our telescopes and everything. If people have never seen this, it's worth it to do it. I took an organized tour that they put us right on centerline where the shadow of the moon cast onto the Earth was going right across this location on the planet. So for 6.5 minutes, it was really dark. And to see a familiar thing like the sun being blocked by the moon is really strange. It was the most bizarre thing I've ever seen in the natural world. People were yelling and screaming, and then you see the corona shining around this dark. It looked like somebody cut a hole right in the sky. And you see that, and it lasts for 6.5 minutes. Everybody's taking pictures. We're all pointing at each other, talking about it. It was really a bedlam out there, organized bedlam, because we're all trying to take pictures of this. And then the moon moves out of the way, and the sun comes back out again. But that 6.5 minutes, it's the most bizarre feeling. And you look around, and the rest of the sky has a very deep twilight look to it. It's just really strange.
Incredible experiences.
Yeah.
And what about some of these other observatories and telescopes? Do they provide different kind of information than what we can get here in Southern California?
Yes. The big thing is, if you're doing ground-based observations of the sky, it's not magnification power that sets these telescopes apart and makes them different from each other. It is the diameter of the telescope, what's called the light-gathering power of the telescope. The more light you can gather, the brighter and more detailed the image will be. So you think about these telescopes, even a telescope that I have here at home, it's maybe 8 inches in diameter. But our eye is only maybe 1/4 of an inch in diameter. The pupil is only about 1/4 of an inch in diameter when it's maximum dilated. So you think about this, which would be able to receive more light? Something that's 1/4 of an inch in diameter, or something that's 8 inches in diameter or bigger? Well, of course, the larger diameter of the telescope, the more light it can gather, the more detail you can see.
And we're going to talk more about what we can see in the sky and why the sky is so important to us with my guest, David Falk, when we return in a moment.
Environmental Directions with Nancy Pearlman continues with further discussion of the world's critical ecological issues. For more information, you may call 310-559-9160 or go to www.ecoprojects.org. Now, here's Nancy.
I'm speaking with David Falk, retired instructor of astronomy at Los Angeles Valley College. We started the program about trying to understand why we should care about the sky and the earth. You mentioned that we get all our energy from the sun, not just for solar panels, but literally the energy to make plants and animals survive. What about the moon? Because I do know that somehow the moon affects the waves, and that might be important in terms of using that kind of energy force.
Yeah, now we're trying to think about putting some of these electrical generators over in the oceans, at least close to the shore, and using tidal effects to mechanically turn wave energy into electricity to power generators, and that's one idea. Yeah, the moon affects us from one sense that it's been around, probably formed right after the Earth formed, so it's several billion years old. It does cause some tides. The weird thing, if you want to annoy your friends and amaze your enemies or vice versa, you can ask your friends at the party, and would we still have tides on the Earth if the moon did not exist? And you get some various discussions about that going. Then you could say, well, weirdly enough, you would have tides because of the effects of the sun. So remember, we're orbiting around the sun, the Earth is spinning on its axis, and we're going to have some effects of gravity affecting the Earth. The Earth is going to respond to the gravitational pull from the sun. Now, the Earth is mostly rock, so it's very hard for that to change, but there is a part of the Earth that can change its shape. That's water, and I'm talking about oceans here. So we will get tides, even if the moon did not exist. But the tides we get from the sun, of course, would be a lot less, and it'd be a little different than what we get from the moon.
Why do we have moons?
That's a great question. We think that the moon may have played an important part for life getting a start on Earth. Now, the Earth has three basic motions. It orbits around the sun. That's what we call annual motion. It spins on its axis. That's what we call daily motion. That's what gives us our day. We're spinning on the axis of the Earth. But there's another motion called precession. That's a weird motion. The Earth kind of spins like a top, spinning very rapidly. But if you ever watch a top or a dreidel, for example, as the top slows down, you may notice that the top will start to wobble, and then it'll fall over as it finally stops spinning. Now, the Earth is not going to fall over, but the Earth is doing this very slow wobble, and it takes about 26,000 years to complete one precession cycle. That means that the north and south poles of the Earth are going to point at a slightly different place in the sky, and that means that the North Pole won't be our pole star forever. It'll change. And in another 14,000 years, we're going to have the star Vega in the constellation of Lyra being our new pole star. Vega is a lot brighter star than Polaris is. Polaris is not the brightest star in the sky. Vega is brighter than it, so it'll make a good pole star. But in any case, we do this very slow wobble. That could change a few things, how we experience our seasons. We'll still have seasons going on, but they may occur at slightly different times as we go through this very slow wobble. This is all an example of changes. We think that without the moon being there, the sun is going to be there, okay, fine. But without the moon, we might have had a much more severe precession cycle, so that the temperature would have varied so much, life might not have gotten started on the Earth, because the moon being there helps stabilize us. As the Earth orbits around the sun is trying to flip us over to have one of our poles point at the sun. But what helps stabilize the Earth, believe it or not, is the moon. It helps prevent this wobble, this precession cycle, from getting too extreme, where it'd have too extreme variations in temperature, and it helps stabilize things here on Earth, at least to some degree.
Recently, there was news about the scientists trying to get an asteroid off its track so it wouldn't come onto Earth.
Right.
Is that really going to be what's going to happen to keep the asteroids away? And what is an asteroid?
So an asteroid is a small body. It's orbiting around the solar system. Usually they're orbiting around the sun in some fashion. Many of the asteroids are in a belt between the orbits of Mars and Jupiter, and there's maybe millions of these asteroids that are out there. Now, they range in size from maybe 500 miles in diameter. Some are just a few hundred feet in diameter. Now, most of these asteroids are orbiting between, like I said, between the orbits of Mars and Jupiter. So they kind of behave themselves. And we think the asteroids, by the way, are probably left over from the formation of the solar system. But there are a few asteroids, a few hundred of them, that are what's called near-Earth objects. These are asteroids that, well, what I like to say is they don't behave themselves. They actually are in a very elliptical orbit, and they tend to cross Earth's plane of orbit. They will cross our orbit. Now, what do you suppose is going to happen if an asteroid is there at a certain location at the same time the Earth is? Bad day on Earth. These asteroids are moving at several miles a second. They have their own orbital velocities, but the Earth is moving too. So if you get a collision between these two objects, it's going to be a very violent impact. And it could only take an asteroid maybe a mile to a mile and a half in diameter to cause an extinction event on Earth. And the reason why there's such a problem is they don't have nuclear warheads on them or anything like that, of course. But just the force of this impact, the asteroid, it would destroy it on impact, but it would release a tremendous amount of energy, including heat and a shock wave that would go out and travel around the Earth. It would kick up so much dirt and debris from the impact that we think covering the Earth. The Earth would be shaded maybe for 6 months to a year until all this dust settles back down on the surface of the Earth. There's a name for this effect. It's called nuclear winter. The effect of all this dust particles blocking the sunlight, that's where the problem comes in, because you drop the surface temperature down to maybe the freezing point of water. That's 32 degrees Fahrenheit. You're not going to be able to grow crops in that kind of low temperature. So all of a sudden, our crops would die. sky and you start having trouble raising crops, trying to get food, it'd be just a miserable situation. You'd have famine happening. The dust itself would probably result in severe problems with the low temperature. People might not be able to survive the low temperatures, so you're talking about an extinction event here.
And we know about what's called nuclear winter, although it wasn't nuclear, when volcanoes exploded centuries ago and really prevented crops from being able to be raised.
Yeah, life was wiped out pretty much on the early Earth a few billion years ago, and we got restarted. Volcanoes could have done that. There's an idea that says that maybe one of these asteroids' impacts was what wiped out the dinosaurs. The dinosaurs were very successful, but 65 million years ago, virtually every species of dinosaur was wiped out. Now, there's some discussion about this. The proof for this lies in a very rare element called iridium that lies on the surface of the Earth. There was a geologist back in the 80s that proposed this theory that it was an asteroid impact that wiped out the dinosaurs. His reasoning was that, being a geologist, he dug down into the ground at different points around the world, different continents, and he found a layer of this rare element called iridium at different layers, but it occurred at a layer of the Earth that would have been on the surface 65 million years ago. Now, the only way this iridium could have been laid down is if an asteroid rich in iridium hit the Earth, vaporized, and all this iridium kicked up into the atmosphere, was distributed around the world through atmospheric winds, and eventually it settled on the Earth at about 65 million years ago. While this iridium, all this other dirt and debris was in the air, it would have blocked off sunlight. Dinosaurs were very successful, but were very specialized. They could no longer find the food that they ate, could no longer find plants to eat because of the low temperatures, and it killed off the plants. So they died. The other dinosaurs that ate other dinosaurs, the carnivores, they could not find food because all the other dinosaurs started dying off, so they died off too. The only things that would have survived were the early mammals, which were our ancestors, these little critters running around on the ground. They would have been ones to burrow into the ground and kind of survive. They were a little bit more flexible. This condition would have lasted maybe for a year, and by then all the dinosaurs were dead, and the mammals took over the world, quite literally.
It's amazing how what's happened in the sky affects us here on Earth, in the past, in the present. You mentioned a theory, and I think we should point out that scientists develop concepts that are theories which are considered facts. It's not hypothetical until proven otherwise. Can you explain that and where people can find out more about checking out the data that's presented and making sure that they get the current facts?
Yeah, there's two sites in particular that people can use. They're open to the public. They're online. My two favorite ones are Snopes.com, and that's spelled S like Sam, N like Nancy, O-P like Peter, E like Edward, S as in Sam. So it's Snopes.com, and that's a debunking site. It's run by journalists. Their mission is to try to check out various popular things that have been stated in the media or just on the street, and they try to check it out and see if it's true or not. The idea is to try to invoke some critical thinking here. It's free, and they'll state what the sources are. They'll give you the information. That's one thing that's important to consider. What are the sources for this information? Is the source reliable or not? The other one is the Center for Inquiry. That's a nationwide organization. If you just punch in Center for Inquiry, all one word, centerforinquiry.org, and that's another organization that promotes critical thinking along a variety of topics from medicine to astronomy and so forth.
You obviously love astronomy. Listening to you, I've got a new awareness of how important it is to understand what is above us as well as what is happening here on this planet. Can we make any changes in terms of making it easier for scientists to discover more information about the sky? What do we do about light pollution?
I'm glad you asked, Nancy. Light pollution is one of the biggest problems that astronomers have, and it's something that affects us. Light pollution, people may not be familiar with that term. It's the idea of light being directed upwards into the sky where the atmosphere scatters it, and you're literally lined up lighting up the sky. The reason why we don't see as many stars, as you pointed out earlier, from the city as we do from, say, outside the city, is not due to smog or fog. It's because of light pollution. This is a major problem. It wastes electricity. Outdoor lighting itself, billboards, street lighting, that kind of thing, that uses about 120 terawatt hours of electricity. That's enough electricity to meet all of New York City's needs for electricity for the next 2 years. And this translates to about $3.3 billion worth of energy. To generate this energy, we're releasing about 21 million tons of carbon dioxide into the atmosphere.
We certainly don't need so much lighting. We can reduce it both at our homes, our offices, and even at our schools and other facilities. Do we need all the outdoor lighting?
No. 30% of the outdoor lighting that's put out there is wasted. It's directed upwards. So we can put lighting down on the ground where it's only needed. We can shield it, and that would be much better. Plus, the type of lights that we use can be arranged better. We use a lot of lighting now that come from light-emitting diodes, LED lighting, and a lot of that light is towards the blue end of the spectrum, which is scattered by the sky itself. We can switch over to light-emitting diodes that are more towards the yellow end of the spectrum, a little bit more towards natural lighting. It gives a more natural glow, and the sky does not scatter that type of lighting as badly.
Where can people find more information about light pollution?
Your listeners can go to the International Dark Sky Association website, IDA.net. The exact website is dark sky, all one word, darksky.org.
I am so concerned about saving wildlife, ecosystems, humans on this planet, not destroying the wonderful life that we have on this planet. So why should I care about what's going on above us in the sky?
Light pollution is one of the things that will affect humans as well as wildlife. If we turn the planet where it's lit up 24 hours a day, we destroy our body's natural circadian rhythm. This is a rhythm that we as humans evolved over millions of years. And it turns out if you overcome that, or you keep our environment lit up 24 hours a day, we don't function very well. The melatonin that's produced by our brains isn't generated, and that starts affecting our health.
I've attended some of your planetarium shows, and they're always different. What do you present?
Our shows at Valley College, there are two basic parts to our planetarium shows we do at Valley College. The first part is generally a live star talk, where we talk about what's visible in the sky that people can see for themselves. And I'm not talking about where you need a telescope. I'm talking about just walking outside and using your own eyes. So we do that live, and that varies month to month depending on what's visible in the sky. The second part of the show is usually a recorded presentation that incorporates music and visuals and things like that. And that'll be on a certain topic. We have a couple new shows that we hope to present soon. One of these shows talks about what the first human Mars mission would be like. We have another show that talks about formation of planet Earth. Gives us a couple new ideas about what we think, how the Earth formed and how it evolved to what we see today.
You mentioned asteroids falling onto Earth. Do we have to worry about space trash that we've put up there that's going to fall down?
Well, the space trash we put up is a factor. It poses more of an orbital problem than landing on Earth. The chances of it landing in a place where it hits somebody on the head is really, really small. And a lot of the space trash just burns up in the atmosphere. It is a problem, but more for orbital satellites. The chance of being collision between orbital satellites, that may be more of a problem. The problem that we face with asteroids is because the asteroids are larger. And like I said, there are many, hundreds, if not 1,000, of these chunks of rock that are maybe half a mile to a mile and a half in diameter. And these are the ones that could pose the problem of nuclear winter, where it could be a catastrophe of putting up so much dirt and so forth into the atmosphere, it would block light.
Some people complain that we're wasting too many billions of dollars on space programs. Isn't there an advantage to learning about space?
Yes, there are several advantages. First of all, the money is spent here on Earth. That's number one. We don't take buckets of money and throw it into space. We have companies, private industries that have been formed to take advantage of the technology that has been developed by NASA and the subcontractors. There is something called NASA Spin-Off. That's a publication that NASA puts out every year that talks about how different discoveries and things that technologies that have been made in conjunction with the space program are commercialized. And this means that people are making money. They're making companies selling products that are used to make our lives better. And this technology came out of the space program, and NASA gives it out for free because NASA is tax supported. So they figure they've already paid for the design or the finding these things out, and they just make the technology available for free. Representatives of companies can actually walk into Jet Propulsion Laboratory here in Pasadena and ask for the Office of Commercialization, and they could find out what NASA has in response to certain problems for material manufacturing, almost anything, and they could find out if there's technology that NASA has made already that they could commercialize and use in their manufacturing, and it's free.
What do you want to discover?
Well, the biggest question I'd like to discover is there life elsewhere in the universe? Are we the only habitable planet? We have not found that out yet. I'd like to find that out.
There's so much we can do to protect our sky as well as enjoy our sky, and I want to thank you so very much for providing your students and the public with these classes and planetarium shows. Thank you for being my guest.
Well, thank you, Nancy, and thank you for having me.
I have been speaking with David Falk, who is a retired instructor of astronomy at Los Angeles Valley College. I'm Nancy Perlman. Thank you very much for joining us, and do tune in again next week.
If you would like free information about these environmental issues, go to www.ecoprojects.org or call 310-559-9160. Environmental Directions with your host, Nancy Pearlman, is a community affairs program of the nonprofit organization Educational Communications and this station.